So before discussing classification of discrete time signal, first we'll discuss what is signal. Signal contains some information. Okay. So the signal may be one dimensional signal or multidimensional signal. Okay. So it is depending on some independent variable. Okay. Here we will be always discussing that the signal is function of time t. Okay. And the signals mainly classified as two types: continuous time signals and discrete time signals. These are the two types of signals. Okay. So we know that most of the signals, whatever occurring in real time, or continuous time signals. So what we do here, so to get discrete time signal, we will be sampling the continuous time signal to obtain some discrete time signals. Okay. And we know that some of the signals are also naturally occurring signals are also discrete time signals. Okay. So for example, we are sampling continuous time signal at t is equal to nt. Okay. So we will be getting a discrete time signal. This we will be representing it as x of nt. Okay. Where small n value will be varying from minus infinity to plus infinity. Okay. So and whereas t is the constant, so this gives us what is the distance between successive samples. Okay. So the distance between successive samples will be always equal. Okay. So we will be representing it as x of n. Okay. So this is about discrete time signals. Okay. Now we'll discuss what are the different types of discrete time signals. Okay. So the discrete time signals can be classified like this. Okay. So here deterministic and random signals. The first classification of discrete time signals can be classified as deterministic signals and random signals, periodic and non-periodic signals, energy and power signals, causal and non-causal signals, even and odd signals. Okay, there are five classifications: deterministic and random signals, periodic and non-periodic signals, energy and power signals, causal and non-causal signals, and even and odd signals. These are the different classification of signals. Now we'll discuss in detail about each of them. Okay. So first we'll discuss about discrete time, deterministic and random signals. Okay. So what is deterministic signals? Deterministic signals will be so you can predict the value of the signal. So there is no uncertainty. You don't have any uncertainty about its magnitude and phase. Okay, at any given instant of time. So those signals are called deterministic signals. Means that you can able to predict what is the amplitude and phase of the signal at any given time. Then that those signals are called deterministic signals. Okay. And the deterministic signals will be represented by some mathematical equation. Okay. So that if you substitute what is the value of n, you can predict what is its amplitude at any given time. Okay. So that is that you can able to predict the signal value. Those are called deterministic signals. Okay. So if you take the naturally occurring signals, the real time signals, all real time signals are non-deterministic signals. So random signals means what? You cannot predict the value of the signal. So there is uncertainty. Okay. There is uncertainty about its occurrence is called non-deterministic signals. Okay. And these signals are called random signals. So in real time, we cannot predict any signal. Yes or no? So all real time, most of the real time signals are random signals. Okay. So the random signals does not have any mathematical equation, so that you cannot predict the value of the signal. So there is no mathematical equation. So this signals, the behavior of the signals will be of probabilistic in nature. Okay. So and these signals can be analyzed by stochastically processing. Okay. So using stochastically we can analyze these signals. That is why PTSP subject will be studied here. Okay. Most of the signals whatever occurring in real time or random signals. Okay, how do you characterize randomness? Randomness is characterized by probability manner. Using probability manner we will be characterizing random signals. Okay. And how do we analyze this? This will be analyzed by using stochastical processes. Okay, using stochastic process we will be analyzing these signals. Okay. And we also know that in the deterministic signals, we will be having some regular patterns. Okay, if you take any deterministic signal will have some regular pattern, whereas non random signal or non deterministic will be quite irregular in nature. Okay, these are in quite irregular in nature. Okay, so uh, and just now we have discussed that the amplitude and phase of the signals cannot be predicted in advance. Okay, so the amplitude and phase of random signals cannot be predicted in advance. Okay, and we also discussed that these signals are called non-deterministic, and what is the example for this is thermal noise. Okay, whereas signals, we have discussed that we have a mathematical model. How do we represent this? Here we will be representing it by x of n is equal to cos omega n. So like that we are using some equation to represent this. Okay, so we'll be having some mathematical equation to represent deterministic signals, whereas for random signals you don't have any mathematical equations, and we cannot predict the amplitude and phase of the signals. Okay, now we'll discuss what is periodic and non-periodic signals. Okay, so a signal which is having definite pattern and repeat itself at regular intervals of time is called periodic signal. So we have a some definite pattern and signal is repeating over a time interval, then it is called a periodic signals. Okay, so if the signals does not repeat at regular intervals is called non-periodic signal or a periodic signal. Okay, so here we are discussing only about discrete time signals. Okay, so discrete time signals x of n is said to be periodic if it satisfies the condition x of n is equal to x of n plus n. Okay, for all values of n. So where n value is varying from minus infinity to plus infinity, for all values of n it has to satisfy this condition. Okay, then that signals are called periodic signals. Okay, then the smallest value of n, here see, if you take any periodic signal which is periodic with the period n, it is also periodic with the period 2n, 3n, 4n. Okay, like that. So, the smallest value of n for which this equation x of n is equal to x of n plus 1 is satisfied, that value of n is called fundamental period. Okay, so the smallest value of n for which the equation x of n is equal to x of n plus n, capital N, is satisfied, that is called fundamental period. Okay, so if the above condition, that is x of n is equal to x of n plus n, is not satisfied for even one value of n, okay, you take any one value of n, for that also it is not satisfied. Okay, only few values it is satisfying, for some values it is not satisfying, then that signal is called a periodic signal. So it has to satisfy for all values of n. If it is not satisfying for at least one value of n also, then it is called aperiodic signals. Okay, so sometimes aperiodic signals are said to be periodic with the period equal to infinity, because aperiodic signals are not repeating. No, when we say that these are periodic, so if you take capital N is equal to infinity, then we say that the signals is periodic. Okay, so aperiodic signals are said to be periodic when the period equal to infinity. Okay, so how do we define angular frequency here? Angular frequency is defined as omega is equal to 2 pi by n. Okay. Now what is n here? N is called fundamental period. So what is n value? N is equal to 2 pi by omega. Okay. So the sum of two discrete time periodic sequence is always periodic. Okay, so if you are taking two periodic sequences x1 and x2, if you add those two the sum is also always periodic. Okay, so now we'll see some examples here. See here, this signal, so the signal is repeating from minus infinity plus infinity, it is having some regular pattern, yes or no? So this is repeating. Okay, so then it is called uh, periodic signal. See here, whether it is repeating, this signal is not repeating, it is only defined from 0 to capital N. Okay, so that is why this signal is called non-periodic signal. Okay, So see this is the example for periodic signal. So this is repeating from minus infinity to plus infinity, whereas this is the example for non-periodic signal. This signal is defined only from minus t to plus t. Okay. Now we'll see this example. So we'll see few examples. Anyway, you have textbook with you. Okay, you can solve these examples. See here. Show that the complex exponential signal x of n is equal to e power j omega naught n is periodic only if omega naught is equal to if omega naught by 2 pi is a rational number. Okay, so we know that when if you take any discrete time signal, for discrete time signal to be periodic, what is the condition here? Omega should be 2 pi into rational number. Okay, then only we say that the discrete time signals are periodic. Okay, so if omega is not equal to 2 pi into rational number, then discrete time signals are non-periodic. Okay, so here we take this example, x of n is equal to e power j omega n, and we have discussed that this signal is periodic whenever we are replacing n with n plus capital N. We are replacing n with n plus capital N, that is equal to x of n. If this condition is satisfied, x of n plus n should be equal to x of n. When this condition is satisfied, then only we say that this signal is periodic. Okay. Now what we do here, substitute n is equal to n plus capital N in this equation. Okay, e power j omega naught n. Substitute n is equal to n plus capital N. So what we get here, e power j omega naught n. So it has to satisfy this condition. E power j omega naught n plus n should be equal to what? E power j omega naught n. Then if this condition is satisfied, then we say that it is periodic. Okay. Now what we do here, we have separated this to exponentials. This can be written as e power j omega naught n, e power j omega n. Okay, so when these two are equal, only when if e power j omega naught n is equal to 1, e power j omega naught n is equal to 1, then only these two are these two. So that is left hand side will be equal to right hand side. So e power j omega naught n is equal to 1. Now we know that e power j 2 pi k. So multiple of k is any constant. E power j 2 pi k value will be what? E power j 2 pi k. See here, e power j 2 pi k value will be always equal to 1. So because it can be written as cos 2 pi k plus j sine 2 pi k. Okay. So cos of 2 pi k value will be always 1, whereas sine of 2 pi k value will be 0, so it will be always equal to 1. So 1 can be written as e power j 2 pi k. So what is that exponential we have? J will get cancelled. We have 2 pi k, no? So it is equal to omega naught is equal to 2 pi k. Now what is omega naught divided by 2 pi? Omega naught divided by 2 pi will be k by n. So it is a rational number. Okay. So it shows that complex exponential sequence x of n is equal to e power j omega naught n is periodic if omega naught by 2 pi is a rational number. Yes or no? So when omega naught by 2 pi is a rational number, then only these two, this equation, left hand side equation is equal to right hand side equation. Otherwise, this equation will not be satisfied. If this equation is satisfied, then only we say that this is periodic signal. Otherwise, it is non-periodic signal. Okay. So here we have some more examples. So check here, you see this example. Determine whether the following discrete time signals are periodic or not. Okay. If periodic, determine the fundamental period. Determine the fundamental period. So what is sine 0.02 pi n? Okay. See here this problem, if sine to 0.02 pi n. So this can be written as sine 2 pi fn. See here ma. we have to compare this equation with sine 2 pi fn. What should be f here? F should be a rational number. If f is a rational number, then we say that this signal is periodic, otherwise this signal is non-periodic. Okay, so find out f, compare this sine 2 pi, sine of 0.02 pi n with sine 2 pi fn. Okay, compare with sine 2 pi fn. Okay, so if you compare these two, we get f is equal to what? F is equal to 1 by 100. Okay, so is it rational number, ratio of two integers? So since it is a rational number, what is n value? N is equal to 100. Okay, so what is the period now? The period n, capital N, is equal to 100. Okay, so after 100 samples the signal will be repeating. Like that we have to solve all these problems. Okay, here also you just compare this equation with sine 2 pi fn. Okay, sine 2 pi fn. So then what is f value? Can you tell me what is f? What is f value? Compare this with 2 pi sine 2 pi fn. Then tell me what is f? What is f?
5 by 2.
F is 5 by 2. Very good. Okay, so like that you have to solve all these problems. Okay, so for example, you take this example, ma. Okay, so here this is non-periodic because there is no pi term. So if you take cos or sine or exponential signal, complex exponential signal, the pi should be present in the signal. Okay, if pi is not present, then it is non-periodic. Since there is no pi, the third C is non-periodic. Now you see here these two are periodic only, because you have pi. If you have pi, then these are periodic. Okay, so we have two periodic signals. Now first find out what is the period of first signal. So that is n1, the period of second signal, that is n2. Okay, so now n1 by n2 you have to calculate. So n1 by n2, if it is a ratio of two integers, then we say that this signal is periodic, otherwise this is non-periodic. So in this case, since both the signals are periodic, this signal is periodic signal only. Okay, similarly you take this signal. See here, so for first signal we don't have pi term. For the second signal we have pi term. Okay, so anyway it is in the form cos A cos B. Okay, so it is in the form cos A cos B. We have to write it in terms of cos A plus B and cos A minus B. Okay, so after writing it in terms of cos A plus B, cos A minus B, then we will be finding what is n1 and n2. So if n1 and n2 are integers, if both the signals are periodic, then it is periodic signal. So if it is not periodic, then it is non-periodic signals. Okay, so like that we have to do. Or directly also, if here if you observe, it is solved directly. So f1 is found. What is f1? We got 1 by 12 pi. F2 is 1 by 12. Okay, since any one of the signal is non-rational number, so any one of the frequency is non-rational number. So what happens here? The multiplication of these two signals will become non-periodic. One signal is periodic, other one is non-periodic. No, that is why multiplication will become non-periodic. Multiplication of these two will give non-periodic signal. Okay, and here you see that the fifth example. If you see this fifth example, this is the phase. Okay, so this term pi by 2 is the phase. Okay, you don't need to worry about pi by 2. We have to consider only which is having n, the term which is having n. So in that, if pi is present, then you will be getting a periodic signal. If pi is not present, then f is non-rational number. F is non-rational number, so it becomes non-periodic. Okay, so this 0.3n we have to compare with 2 pi fn. 0.3n we have to compare with 2 pi fn. Okay, Then find out f. If f is non-rational number, then it is non-periodic signals. In this case, it is non-rational number. So what type of signal it is? It is non-periodic signal. So this signal is non-periodic signal. Okay. So anyway, this is complex exponential. Pi is also present in this. So this becomes periodic. Okay. So then to find out what is the period, you have to compare this with 2 pi fn. Okay, so see that just now we have discussed, no, is it periodic? Periodic only. Okay, so like that we have to compare all this. Okay, so you have a sum of three signals. The first signal is 1. Okay, so if it is 1, what is that? It is a DC signal. What is the period of that signal? Will be 1 DC signal. If x1 is 1, it is a DC signal. What is the period of that signal? Will be 1. And for all others, you see here, for all others anyway pi is present, so you will be getting periodic signals only. So the second signal and third signal is also periodic signal. Okay, so here we get n2 n3. You observe n2 n3 is also uh, what is that, you get a number. Okay, so then we have to check, just now we have discussed, no, n1 by n2, n1 by n3 have to find out, okay, whether it is rational number or not. If it is rational number, then it is periodic, otherwise it is non-periodic. So it is a rational number, so it is a periodic signal. Okay, then to find out what is the period, what we have to do, since we have more than two signals, if you have only two signals, then we will be just cross multiplying and finding what is the period. See here ma, if you have only two signals, say n1 and n2, okay, n1 by n2, we got some k by m, some ratio of two integers, that is k by m. So what, how do you find out n here? N can be found like this. So it is m1 into n1 into m into, that is equal to n2 into k. So if you have only two signals, then we will be finding the period like this: n1 into m, that is equal to n2 into k. So using that we have to find out what is the period. Okay, now if you have more than two signals, so in this case we have three signals. If you have three signals, what you have to do, we have to find out the LCM of those three. Okay, so the LCM of n1 n2 n3 will give you what is the fundamental period. Okay, now we find out what is energy and power signals. Okay, signals can be classified as energy signal and power signal. Okay, depending on the energy and power of the signal. So we have to find out what is the energy and power of the signals. Okay, so the total energy of a signal is given by the formula E is equal to summation n is equal to minus infinity to plus infinity mod x of n square. Okay, and how do you find out the average power? Average power can be found by using the formula power is equal to limit n tends to infinity 1 by 2n plus 1 summation n is equal to minus n to n mod x of n square. Okay, using this we will be finding the power. Okay, now if you want to find out the power over one period, okay, how do we find out the power here? Power can be found by using 1 by n summation n is equal to 0 to n minus 1 mod x of n square for discrete time signals with x of n is equal to 0 for n less than 0. So we are just finding the power in one period. Okay, so this is the average power of the signal. Okay, this is the formula we have to use to find out the average power of a signal. So when you say the signal is called energy signal, so the signal is called energy signal. Okay, if the total energy, if the total energy of the signal is finite, okay, then and what is the power? The power should be 0. Okay, so the energy should be finite and power should be 0. Then the signal is called energy signal. Okay, so for energy signal, what is the total energy? Should be finite and power should be 0. Then these signals are called energy signals. And most of the case, non-periodic signals are called are usually the energy signals. Okay, so all non-periodic signals are usually energy signals. Okay, and similarly, what is power signal? Power signals uh, will be having, see, the energy of power signal is always either zero or infinity. Usually the power signal will have infinite energy. Okay, and what is the power will be finite. Okay, for power signals the power will be finite. Okay, what should be the energy for power signal? The energy for the power signal will be infinity. Okay, so that signals are called power signals. So we have some signals, for example, okay, the energy of a power signal is always either zero or infinity. Any periodic signals cannot be energy signal. Okay, you take any periodic signals cannot be energy signal. Okay, whereas periodic signals are the examples of power signals. Periodic signals are examples of power signals. Okay, so see, you have to remember only this thing. What is that? Energy signal will have finite energy and power is zero, whereas power signals will have finite power and energy is infinity. And the periodic signals are usually power signals, non-periodic signals are energy signals. Okay, so if we have discussed that energy and power signals are mutually exclusive. If you take any signal, that signal can be energy signals or power signal. Okay, it cannot be both energy and power. Okay, so no signal can be both energy and power signals. Okay, now you take any signal which does not satisfy these two conditions. What is the first condition we have discussed? The first condition we have discussed that energy signal should have finite energy and power should be zero, whereas power signal will have infinite energy and finite power. Yes or no? So if any signal does not satisfy these two conditions, then those signals are called neither energy nor power signals. Okay, so we have, for example, you see, the signals don't satisfy both above properties, neither energy signals nor power signals. Okay, so what are the examples? The examples are x of n is equal to u